Greetings. I am Mark, W0MH, Brainerd, Minnesota, USA. I was first licensed in 1962 as a novice, WN0AXD, Morse code novice. My father was a radio broadcast engineer going back to the 1920s. All broadcast engineers were hams back then. I always knew I would be a broadcast engineer from a very early age, but I took 3 years out to serve with the U.S. Army, including a year in Vietnam, 1968 to 69, doing high-tech electronic repair on the OV-1 Mohawk surveillance aircraft. I retired after 44 years of radio broadcast engineering as a contractor, which included building 12 new radio stations. Paula and I had the opportunity. We designed and built a new home in 2003. This gave me the opportunity to configure the wiring exactly the way I wanted it, much like that in a broadcast facility. Let me share a screen. And what you see here, oops, there we go. What you see here is our ham station. Now, you'll see QSL cards on the wall, much like your station. Above Paula is an on-air light. Well, gosh, as a broadcast engineer, who wouldn't do that kind of a thing? And then there's a 2-meter all-mode transceiver here up high on the shelf there. And then there is on the right is a watt meter. Down below, we've got a 2 kilowatt dummy load, antenna tuner, ICOM 7300, and an Ameritron AL 80B. And I want to move on to show you something important that I built recently. And I wrote an article for CQ magazine. It's an RF relay. And this relay, in essence, disconnects the rig from the antenna, at least the center conductor of the rig coaxial cable, and it's automatic. So if I forget to flip the switch away from the antenna when I leave, this does it for me because it works. The relay pulls in when the transceiver is turned on, not transmit, but just plain turned on. And take a look at the SO239 connector on the right. It from the center of it, there is a conductor, and I've added some extra braid here to reduce the inductance over to the armature on a relay. And in the relaxed position, that center conductor is shunted to ground. And the antenna is a little bit higher up in the photo. Same deal. It is connected to ground. Now, when the transceiver is turned on, the relay pulls in, and the center conductor of the rig goes to the lower contact here, which then goes to a brass bolt to the other side, comes out of the other side, and goes to the antenna. That is a neat little trick. This relay is a standard 120 volt, 240 volt relay. This one just happens to have a 12 volt coil. It's capable of 30 amps and certainly more capable than anything that you and I as hams would put through it. Let's look at how the station is configured. You'll notice that I don't do calculations well, so today's clock, the local time, is on the left, and Zulu time is on the right, so I don't make any dumb mistakes. One thing I really like at the center in the middle is a clear speaker. It's digital noise reduction, works like $1,000,000 for me. Now, what I'm trying to tell you about here is that I have a 5-position switch for selecting what antenna I'm going to use at that time. And there's a companion switch on the right. When it's in the normal or the right-hand position, then all is well. The linear amplifier goes to the antenna, and the antenna analyzer, which you see up here, which is permanently wired in, by the way, looks at the dummy load. But when I flip it to analyzer, then the analyzer is looking at the antenna, telling me how the antenna looks at this time. You'd be amazed at the number of times I've had to go out and look at the antenna to see that there was a broken wire or something when I flipped on the analyzer without ever putting a watt of power on the air. I knew that right away. So that is a really convenient thing. I do that every time before I go on the air, and I do that with a relay much like the one that I just showed you, only I configured it as a 4-port, 2 inputs, 2 outputs. In other words, the rig to the antenna, and then the analyzer goes to dummy, as I mentioned, or flipping the switch, the rig goes to the dummy, and the analyzer goes to the antenna. And all it takes is a simple flip of a switch, and you got it. Now, you probably do this, and for those of you who don't, I would say write down all the settings on your linear amplifier, so you can easily go back and find where your dial settings should be when you change bands. And this is especially important on the tuner for my all band antenna. There's no way it's going to give me 50 ohms at any frequency without some adjustments. This is the tech room. This is the part, since I like to build things, this is what I do. What you have in the upper right-hand corner is actually the incoming power from the city. It's a circuit breaker shut-off panel. And from there, it goes to some ductwork, goes over to this Kohler power transfer switch. There is a 22 kW fully automatic generator plant that keeps the power running when the city utilities are down. From there, power goes over to two 200 amp panels. I've only got 200 amps of service, but it gave me the chance to put lots of breakers in because I put lots of circuits in the house. And all the lines coming out of the top, they're all labeled, and there's actually 2 stacked on top of each other. So it's twice as many as what you think you're seeing right there. To the left is a circuit breaker panel. It's a 100 amp panel. It's only carrying less than 30 amps of 120 volts, but that's for, if you look on the lower left in the racks, there's 2 equipment racks here. You'll see a 3,000 watt APC uninterruptible power supply. Oh, and what it does when that power supply is running, it keeps the phone system going, it keeps the alarm systems going, and the internet going, all those things in the 10 seconds that it takes for the generator plant to come up and start supplying power to the house, and it's all fully automatic. Let me show you the batteries for the UPS. Instead of leaving the batteries in the UPS, I set them out in the back because I found that batteries run warm in cabinets like a UPS, and their life is reduced. So in this case, I have them out so they stay nice and cool. I put a voltmeter on them so I can watch them. When I do a test, I can watch the voltage drop, and if it drops more than I think it should, then the batteries get replaced. That voltmeter had to be powered by a wall wart transformer. No big deal, but that's just the way it is. Now, the UPS can be disconnected easily. On this box on the right, you'll see that's city power or the building power being delivered to the UPS. The UPS plugs into it. And then there's a cable out of the bottom of this UPS box, and it plugs into the UPS. So if for some reason the UPS fails completely, I can in seconds bypass it by just unplugging one and plugging the other one in. Now, I showed you not a very good view before, but this is more detailed. This is below the 240 volt part of the installation. And what you see here is a copper strap. That is a common point ground. There are multiple ground rods outside the house that tie into this first electrical panel. And that panel has this copper strap on it. And then the strap goes all over here and over to the rack. But on the way, it picks up telephone, cable TV, you name it, and make sure that their outer conductor, they're shunted. Any high voltages get shunted to this copper strap. It's also connected by this conduit to the city water pipe, which is copper in the basement. Now, you'll notice that in this area, cables come in from the tower. There's actually two conduits to the tower. I've only populated one. One is for, in case something goes wrong, it's buried next to the first one. So cables come in, they make a few turns, and then they go to these surge protectors here that are just bolted down to that copper strap. So you know for sure that the outer conductor of the coaxial cable is at ground potential. And then these have little gas tube protectors in them to give us additional protection to the center conductor. Here's an example of a 4-inch diameter transmission line at a local broadcast facility. There's over 40,000 watts of FM RF energy going up this coaxial cable. But the little cables, the 1/2 inch and 7/8 and all that, they run over to this common point ground also through braided strap like that. Now here's you know who on his tower, me, and it's a 65-foot tower. Really, it's an 80-foot tower, but there are 15 feet in concrete buried in the ground. Now, how did I come on this? Well, it started out as being a 200-foot tower at a radio station at one time, and it was taken down. And you can't insure something like that. You can't insure a used tower when you put it back up. So it was in essence given to me, and I had to clean it up a lot, of course, and then do all the extra work to get this tower up. Here's a better view of me on the tower, your favorite ham working on his antennas. So what do you see here? First thing at the top is this white fiberglass whip, 2 meters, 440, and it's right, it's where it belongs. And then if you see just below it, you'll see a little coil of coaxial cable. That's so that if I ever have to replace the connector on the end, I've got something to work with. Below that, you'll see a couple of wires. That's a dipole. It's an all band. It's like a 160-meter dipole, and it's fed by 450 ohm ladder line. On the right, you'll see it's a 20-meter inverted V with a balun. And you'll notice there's some coaxial cable would have gone to the balun, but I had taken it apart because here I am making a change. And the change is this piece of aluminum here with a new balun on it from DX Engineering. And I'm going to extend it out from the tower a little bit. And so I'm sure glad I had extra coaxial cable so that I had enough to go out to the new balun. And then, of course, I'll tighten up the inverted V wires and away we'll go. On the upper right of the tower, you see this static dissipator. It's stainless steel points. And if you do some research, you'll find out that this is a wonderful way to reduce static buildup on the tower and a potential lightning strike. This is what one looks like up close. And again, it's just stainless steel points. They cost about $75, I think. Cheap at twice the price. You can build them yourself. There's no magic here. It's just sharp points. And the reason why it's stainless steel is it's so it won't corrode. Here is a commercial installation on top of a tower with, they're fatter points, but still lots of them. And then here is a surge breaker. It's a plug-in unit that goes in an electrical panel at home, and it it goes where a 2-pole breaker would go, only it prevents voltage spikes from going too high. And the key here is that breaker, that surge protector, should be right near the incoming power, not at the other end, but as close as possible. Here is the 22 kW generator plant that I mentioned earlier. It's a Kohler. It has a Ford 4-cylinder industrial engine in it, and it runs on propane. And it's all self-contained. It's just terrific, and it works great. And Kohler puts these marvelous controls on that control the speed. Well, what's important about the speed? Speed means 60 hertz, not 59 or 75, but 60 hertz. Here's the transfer panel that makes that generator come online. On the right is a circuit card that looks at incoming city power, and it waits to see if the power loss lasts a full 5 seconds. And if it does, at that point, it then sends a signal to start the generator. Then it looks at the signal from the generator, the 60 hertz, 240 volts, and only when it's got to 60 hertz, within 1 hertz, I think, and the right voltage, will it then switch the power to the building. Let me show you the wiring. City wiring comes up here in the middle, goes up to the relay where it's labeled city, and then the output part comes down slightly to the left, and then the generator power comes in from the rear and plugs into the gen part of the relay. And the neutral is isolated as required by the rules. Here is what utility power looks like here. There's about 2% harmonic distortion. That means that 98% of the waveform is a pure 60 hertz waveform, but 2% of junk is added. What we don't have is a nice peak at both ends of the sine wave, and there's some extra jitter in there. Anyway, that would be normal power today. This is what the Kohler looks like. It's able to overcome that peak shaving thing because it's doing real active voltage control. It's a few little wiggles along the way. And this is loaded now, as in it's got a full load. Well, not a full load, probably got about 50% load at this point. And it looks pretty good. And it's about 2% harmonic distortion too. Here is what the UPS looks like. It's trying to generate a 60 hertz sine wave from digital. So it's got its own little problems, but it's still pretty good. I think it's under 5% harmonic distortion. Here is a typical backyard generator plant, and it's approaching looking like a square wave. And this is where, when you put an uninterruptible power supply on, you start to notice that, hey, the UPS doesn't like this anymore. Here's a popular Sportsman 4 kilowatt gas-powered generator with a 50% load. And the load is real simple. It's just a heater, just purely resistive. And it looks like that. More problems with UPSs. This is a Winco. Now it's ground-mounted propane. No, it's natural gas-powered 8 kilowatt unit, and it has very poorly run, very, very poorly designed controls in it. That's my take on it anyway. This is the waveform you get. UPSs do not like this. We were talking about lightning earlier. Here is what a lightning strike can look like. This is a utility pole, like a 40-footer, and it's next to a studio building. Lightning decided to strike, split out part of the pole, jumped over to this antenna. So what is this antenna? It's a microwave antenna. It's used for 950 megahertz to send audio from the studio to a transmitter, maybe as much as 20 miles away. It's just 10 watts in, and the antenna multiplies it to be, 100 watts or more, but that's standard practice in the radio broadcast industry today. Well, when lightning struck, one of the things that took out was this gigabit switch, which is no longer a gigabit switch. And computers, that it really made a mess out of the facility. And this is all of this was toast, and this isn't all of it, but we're talking many thousands of dollars worth of gear here that, in essence, became toast after the lightning hit. Here is a schematic from the top down of what a transmitter plant should look like in the broadcast world, especially for an AM broadcaster. If you go to the lower left, you'll see that the AC power comes in and there's a surge protector. So if there's spikes, they get taken to this station reference ground. It's a single point ground. And it's connected to the ground system all the way around. And then there's some extra ferrite chokes just to keep the lightning from wanting to go to the transmitter. And on the right, you'll see a coaxial feeder to the antenna coming in. And its shield, its coaxial cable, just like at my place, goes to the station reference ground, the single point ground, and as added insurance, there's an extra ferrite choke on there. You'll notice that the transmitter's ground, it does not have a ferrite choke on it. You want it to be a good ground. And the other equipment, the audio processing, remote control, all that, it gets a ground too. So this is what it would look like as kind of a 3D view here. Transmitters in the broadcast world are typically 6 feet tall and maybe 30 inches wide and 30 inches deep. And in this case, the antenna that comes in on the upper right takes a long route. It goes over to where the electrical panels are and that single point reference ground before going to the transmitter. Some transmitter sites have been built without that thought in mind. The coaxial cable, naturally so, would come into the building and just go to the transmitter. Well, lightning hits, then it follows the transmission line, and guess what? It goes through the transmitter on its way to ground. Now you're talking transmitter damage. Speaking of grounds, when you have a 3-wire power cord, the manufacturer knows that you need to have a good safety ground on there. Please don't put adapters on like this. It defeats the purpose and gives you potential liability problems. Now, I climbed my tower, and one day I was climbing a few days before what you see here, and I was stung by a hornet. Well, after I recovered from that, I called someone who has a beekeeper's hat and beekeeper's gloves. And I took vengeance on those beasts. I went up there, and boy, you should have seen what they looked like from the inside of the beekeeper's hat. They wanted to get me in the worst way. Well, I gave them heck with hornet spray like this. A few days later, under sunny and blue skies, I climbed up there again with the same hat and gloves, just in case some of the relatives came to visit. And I chipped away, you see me chipping away the remains of the hive. And this is me, the tower climber. You'll notice that I'm all wet. Well, that's because I walked through the sprinklers on the way back. And you'll also see that this is an OSHA approved climbing harness. So anyone who does climbing should use one of these. You'll notice that there are 2 large hooks in my hand there. And those, actually there are 3, but 2 are showing here. And you always have one of those connected at all times. So it makes climbing slower, probably makes it twice as long to climb, but only about 100 times safer than it used to be. And that's my story. And so here we are back at the beginning with Paula, my wife, and I at our ham station. Oh, by the way, you'll notice the on-air light is lit because she's pushing the button to turn to go into the transmit mode. Let me get out of this. stop the share, and we're back here again. Anyway, I just wanted to say I hope this has been educational, and I hope this helps you improve what you're doing in your quest to have that best station on the block.
Thank you so much, Mark. That is a fantastic presentation. I have a quick question for you while folks are organizing in chat their Q&A. How long is the longest period that you've run the station on emergency power?
25 and a half hours. That tornado came through town, a town of 13,000 people, cut off both paths of the power from the main substation. There was a north going one and a west going one. Tornado cut across diagonally, took them both down, and so we had power and almost no one else did. And the food markets were throwing away food and the whole business. It was quite a mess. The whole town was down, 13,000 people.
Wow. So you had a real world example of emergency power working for a station. So Brian says, great presentation. Thanks. And Michael also shares a compliment about this wonderful setup. The most excellent from Steve Hall.
Oh, thank you.
And a question, what is best for protecting Cat5 Ethernet?
Well, are you talking about within a home? See, I got my common point ground, so everything just reaches out from there. So I don't see a particular problem there. If any, I fear the thought of running Ethernet out to my outbuilding, so I haven't done that. I felt that it was too much of a risk to cause a problem. But you remember at the radio station that was hit on its microwave tower, it it was the microwave antenna, and because the lightning came in on there and had to find ground somewhere, it just happened to pick the Ethernet to do that. I don't see that as a problem happening in my place. Of course, I could be proven wrong on that one too.
Okay. Brian follows it up and he says he has Ethernet going to his tower underground.
No, only coaxial cables. So no, it's one of these days we're going to want to do that, and I'm going to say, and how am I going to do this? And I think it's going to come down to probably fiber. And then fiber, you're great, you're protected.
Yeah, good point. The next question is from Walter. It says, thanks for a great presentation. He says, studied NEC back in the 90s and I'm familiar with grounding and grounded circuits. So more of a comment than a question, but a compliment for the presentation.
Mike, Michelle, you said that you learned the hard way that UPS doesn't like bad generator quality, and then you said you broke one. What was it?
Yeah.
The UPS or generator or what?
Yeah, the UPS failed. So yes, the whole section that you have in this presentation about comparing the qualities of different generators. So I did destroy a UPS on a bad generator. This was a ill-advised experiment for field day.
Well, I do know that UPSs need to run, they have smaller batteries, and the intention is that they don't run too long because they can overheat. And gosh, when they overheat, bang, easy to have them fail.
Indeed. I think that's probably what happened to mine. Donald asks, what book or resource do you recommend for a simple setup at small home and station?
I don't have one for you, but just follow the lightning. Find your single point ground. Make sure that everything you have is connected to that ground, and 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 don't bring a cable in from the opposite side of the house for your ham station, because again, your antenna will pick up the lightning. It'll go through your rig on its way to the electrical panel. That's why I designed it so that it all happens at one point.
Dennis says, nice job, Mark. The power distribution is first rate. And hello, Michelle. And thank you, Dennis.
Regarding the power distribution, this is our second home that we built in this fashion. And I, I took great pride in doing all of the electrical work. Um, Now, I had to check with the local electrical inspector, and I said, "This is what I want to do. Are you okay with this?" And he said, "Yes." And so, in the process of doing it, I must have called him 6 times, and I says, "I got a question. What should I do now?" And he just told me what to do, and I did the right things. Not all electrical inspectors are that agreeable, but under the law, at least in Minnesota, if I'm the homeowner, I can install all my own equipment, although inspections are required. So I made sure that all of what the inspector told me to do, I did.
That sounds like good advice. Bill asks, do I need to use copper strap or would copper pipe from the hardware
Mhm.
store work?
Okay, that the copper pipe would work. In broadcast, AM broadcast, we use strap because of the surface area. Now, we're talking about like an AM antenna where the ground system is linked to the transmitter, and well, it's all linked together at the base of the tower. Uh, Ground system is 120 radials, quarter wavelength. So if it's a station on 1300, those radials going out like spokes of a wheel, number 10 copper, typically 150, 170 feet, let's say. So 120 of those. And then, like I say, the copper strap has surface area for electrons to flow. A pipe can do it too. And interestingly enough, I've seen some designs in transmitters where they use a pipe, maybe they silver plate it, but they'll drill a hole in at each end so that electrons can flow in and out of the inside of the pipe. Why is that? Because at radio frequencies, the electrons flow only a few molecules deep. So the heavy pipe is great for, say, carrying 60 cycle current, but it's the surface area of the copper that's the most important.
Jeff asks, have you experienced RFI problems with ARC fault circuit breakers that are now required for new construction?
Oh, that happened since I built the house. So I have no experience with that. I am hearing that people are having problems and they have to go out and find a different brand. And that's a likely problem because they're looking for the slightest little thing to happen and boom, they shut things down.
Jeff also compliments the presentation.
Oh, I know, Jeff.
Very good. Mitch says, great job, Mark. And hi from a pile of people in Vermont.
Oh, and all those radio stations. Great.
Yes.
Oh, what a call. WVMT, Vermont. Love it.
Lionel asks, will you please discuss tower grounding?
Well, in my case, I didn't plan my tower as an AM radiator or as a radiator. I just used it as a support element. If I was to turn it into a radiator, say like an 80-meter vertical, uh, I would deploy probably a minimum of 10 ground wires, number 10, soft drawn copper, out like spokes of a wheel, out to quarter wavelength. That would be pretty standard. Now, how would I feed a tower that is grounded at the base? There is a technique that we've used in AM broadcast called unipole, where 3 or more wires are 30 inches from the tower. They go up the tower and they join the tower at about the 50 ohm point. And then you feed those wires to that point. It's another way of doing it, but my can get complicated.
It certainly can.
Oh, as far as grounding my tower has at least 5 ground rods going straight down, and I try and space them apart, like more than 5 feet apart, so that if you have 2 ground rods right next to each other, that's the same thing as a fat ground rod. You if you spent the money on 2 ground rods, get them out from the tower.
Oh, good advice. Michael asks, is your setup installed on sheet rock or hard rock? And
Oh,
wouldn't it be safer to have the lightning protectors outside rather than inside?
mm. Well, first of all, I should have mentioned the equipment room. All the walls and ceiling are 3/4 inch plywood, so it'll hold everything. I can put a big electrical panel on there and just screw it on. It works like great. The lightning, I I just feel that I don't like things outside. I would rather have those cables come to a nice dry place. And as you notice, they didn't come very far into the room. And did you also notice that there are some turns in there? Well, I kind of planned that ahead. I knew I was going to pull through the conduit more cable than I would need. Obviously, you don't want to go short on that. And I thought, well, a turn is inductance. So lightning is not going to want to follow that 50 ohm line into the surge protector. So there's an additional protection with just a couple extra feet of cable. And no, I don't know, more turns are better, but that's what I had. It's a couple turns each, and that worked.
Steve compliments you on a great presentation.
Great call. Try nitrotoluene, TNT. Great call.
Very good. So please continue to ask your questions in the chat. I have a question for you. For a typical amateur station, what's the one thing that you recommend people look at first?
Oh, well, antennas, I think, are more important than the radio itself. Almost any radio will do the job for you, but antennas, if you got a lousy antenna, you got a lousy station, and they don't have to cost a lot of money. I mean, what does it cost to make a dipole? Just some wire, no big deal. One time, we said put half your money into your antennas, which makes a lot of sense, but it doesn't have to be half. Of course, if you want to put up a beam and a tower and all that kind of stuff, well, sure, go ahead.
Very good. Good advice. In terms of your area of expertise, which is substantial, we've talked a lot about the actual technical equipment for the station. Do you have any advice for how to lay out a station physically like how did you choose to arrange your equipment in the station, and what do you do in order to make it comfortable to use?
Hmm. Well, it's on the end of my workbench, which is like 20 feet long. It occupies about maybe a quarter of it, and I didn't do it as quite the best way. There was a ham I met on Washington Island, Paula and I actually went there to stay at the resort. His wife runs the resort, and he's got the ham station, and he's got like 100 radios. Well, how does he get around to work on those? So he actually designed his ham shack so that the outer walls are huge doors. Can you believe that? So if he wants to change the wiring, he goes outside the shack, opens these gigantic doors, makes a change, and closes them again. Can you imagine that? It's like removing a wall to get to the equipment. And I guess my ham shack in this case is just like everybody else's. And I normally you'd think of a ground bus behind your equipment, but if you think about the single point ground that started out in the tech room, I consider that just fine. And yeah, maybe I should tie them together at the ham station, but they're all tied. All the pieces are tied with coaxial cable anyway, so I think they're okay.
Pretty good. All right. Mitch asks, at field day, we have a ground rod at the tent and tower, but the generator is over 100 feet away. What is the
Mm.
best way to ground the generator, if at all?
You're talking multiple grounds, one out at the generator, one at the shack, and ideally, geez, that's a tough one. You you should have a ground rod where the power comes to the operating position, and ideally you'd have a metal box that the power from the generator comes to, and then goes to that ground rod, and before the wiring the power continues on to the rigs. You and by the way, the antennas need to tie to that same single point ground, the spot where the generator power comes in. And I suppose I might be tempted not to put a ground rod at the generator, but it's kind of code to do it, so you kind of have to. So you wind up with two. If you had, say, a number 6 stranded cable, you'd tie it to the ground rod at the generator, tie it to the generator, bring that number 6 back to the station single point ground, and the electrical box that be there, the metal neutral and ground, and tie it at that point, same where the antenna goes.
Steve Hall asks, do the common outdoor commercial bronze clamp-on connector, the wire to ground rod, corrode over time?
Yeah, they do. They do. So it's a maintenance thing. Just do the best you can. Now, you can weld them on. I didn't do that, but that's a common thing called CAD welding, I believe, and it just fuses the ground rod to the ground wire. That's a really good way to do it, and it's expensive and all of the above.
Paul asks, my electrical ground is on the other side of the house from my shack and tower. What's the proper way to bond?
Yeah. Well, I'll say it again. You bring in your antennas and your power. We bring your antennas in and tie them to the electrical panel, the official ground rod of the station. Now, that might be halfway across the house or all the way across the house. And you wind up bringing them like the coaxial cables all the way to the electrical panel, bond the shield on there to the electrical panel and its ground, and multiple grounds rods is a good choice too, before you do the U-turn and go back to your equipment. I'm sorry, that's the way it needs to be, because if you think about where lightning's going to go, it's going to pick the shortest path to get to ground, and if the shortest path is through your rig to ground, you got troubles.
While we're waiting for more questions, I'm curious if you have a checklist of regular maintenance that you go through and what would be on it.
Oh, well, the generator plant gets tested once a month with a load on it. Once every 3 months, I actually do a full system test where I actually shut off the city power, wait the 10 seconds for the generator to come up online. And in part of my testing, I look at the battery voltage on the generator. You might have noticed on top of the panel there was a charger. I built a charger for it, and a voltmeter. So when I'm doing my test, I see if the voltmeter drops down to 9 volts, that battery's got to go, and I'll put a new one in. Um, the other thing is on the UPS, as I mentioned earlier, I look at that voltmeter, see if it drops significantly, batteries go. Um, it's I guess I do this because I was a broadcast engineer, and we always did these things because, gosh, it'd be egg on my face if a generator didn't start when it's supposed to. Thank you. So, you know, it's keep your job. By the way.
Now, we've seen the type of generator that you've selected as backup power, and these are pretty common. What do you think about battery backup? Since there's a whole bunch of new batteries available for house power, And also because of the prevalence of electric cars, so more and more people are
Mm.
paying attention to these battery powers. Is that a good option to look at? Is there anything that people need to know in terms of selecting between a generator and possibly batteries?
Well, I guess I'm old school, and I'd go with a real generator plant. It depends on the size of the batteries. Now, that 25 and a half hour outage, could the batteries keep going for that length of time? And for us, being a broadcast engineer and all of that in business, I had to go to transmitter sites and all that. That meant that the garage door openers had to work. Everything had to work. The shop, the soldering irons, everything had to work. Air compressors, everything had to go. So, um, batteries are more common. Tesla's doing a lot of that. It's fine, but for 100% reliability, I just went with the real generator. And as I showed, they come in a lot of different quality levels. Generac is a well-known brand. They've got 50% of the market for homes, I guess. I Yeah, early on, they weren't so great. I guess they're better now, but I'm just a big Kohler fan because they just work. They're very tight controls, and they just plain work.
Very good. What is the next thing that you want to add to this station?
Oh my! Oh gosh, boy! Now you got me going. Ask another question. I'll come back to it.
Okay, so we'll hold that one. Is there any other questions from chat?
Hmm. All right.
I think
Well,
you're free to tell us your list of things that you'd like to add next.
oh, I keep working. I never stop building, and just I'm more of a builder than I am an operator. And I know most people, I get called over to my friend's house. They tell me I'm an operator. I'm not a repair guy. So what do? I go fix their linear amplifier. So I do that. Oh, I don't know. I'm pretty much where I want to be at this moment. Although I'm waiting for ICOM to come out with a new rig that would have antenna pre-selectors. There's a brand out there that actually has better antenna tuning on the receive side. And the transceiver I have is the ICOM 7300. Well, that's one of those software defined radios, and they're absolutely fabulous, except they don't have some good tuning in the front end. So I could be overloaded by local things. And speaking of local things, I here I am, a ham, and hardly a mile in one direction and less than a mile in another direction. Two hams I know who are very active, and both of them run plenty of power. So we, I sometimes wind up colliding with them on making contacts. So yeah, I would say that the ICOM's next. I'm an ICOM fan. I think their next one might be my next purchase.
Oh, very
So
good. So
yeah,
that's on your list.
I guess it is on my list. But if I were to add any better antennas, it would be a cubicle quad, uh, which would be like 10 through 20 meters, that kind of thing. And I'm a little worried about my tower, as I mentioned earlier, Michelle, in that uh, I shouldn't guy the tower. It's freestanding, 65 feet, because it's really strong. But if I guy it and a tree falls on a guy line, it could pull the tower over. So I'm thinking that a guy line guy lines might be required if I put a bigger antenna at the top, and then I'd be into that possibility of taking the tower down. So maybe if I cut down all the trees around there, and I'm sure the neighbors would love that. So
Yeah, that would be a, a big deal
mm,
considering all the trees that were in the
mm.
photograph in your presentation.
Yeah, I should tell you a story about switching power supplies and something that happened to me recently. I was when I went to meet my friends on the quarter century wireless net Saturday morning, a real common thing. all noise up and down the 80 meter band, not just on our frequency. So I wander around outside with a transistor radio, Sony 2010, and it leads me to the garage of my neighbor. Well, what happened? The night before, he had plugged in a brand new switching power supply that is a smart battery charger. So I I took it to the shop. I looked at it, and then I told Ed Hare at the ARRL, Ed, at W1RFI, radio frequency interference. What a call, huh? And that's his job at the ARRL. He runs the lab there. So he wound up getting one of these battery chargers and analyzing it, found out that it made all kinds of noise that was outside of the FCC rules, Part 15 rules. It's called an unintentional radiator. Think about it. When is a battery charger supposed to be a transmitter? Who would have thought of that? Well, all of a sudden, harmonics of the switching going on in there just spread its way up to practically 30 megahertz. So anyway, so he did the analysis, and he's going to submit something to the FCC saying, hey, now here's another point. If you at home discover that you have problems with noise, and you know what the noise generator is, let the ARRL know. They are looking for these sources. They want to test them. They want to report them to the FCC. We're living in a world of switching power supplies, and it's true, most of them are compliant with the rules. The hard part is that there's so many of them. So if each one adds just a little bit of noise to the spectrum, the total accumulation brings the noise floor up. I'm fortunate enough to live in a neighborhood where it's all underground utilities. So that really helps a lot. And I drive through town where there are overhead power lines and listen to the AM radio. And boy, you ought to hear some of the buzzing I hear. And it's just, it's too bad. But but that's not all of it. The switching power supplies are a big contributor, and a switching power supply can be connected, can be plugged in at the house, and all of a sudden those power lines, the overhead power lines, are big transmit antennas. Remember, an antenna can be used for transmitting just as well as receiving. So there's no magic in it's just a transmit antenna, remember.
Oh, excellent points.
Yeah.
Bill asks, do you have wiring diagrams for your antenna and analyzer switches?
Oh, no. Oh, yes, I do. I have documentation. I I'm old school. Uh, file folders. I draw schematics, and that's for each individual unit, and then put them in there so that if I go back and want to make a change, then I know what I've where I'm going with that. And when I look at a schematic diagram, I say, "Oh, well, I understand what's going on." But when I open a box that doesn't have a schematic, it's like trying to drive from here to Connecticut without a road map. I mean, it's really tough. Schematics really tell the story. So anyway, keep good documentation on everything you do, except in my case, I don't have it documented as to what box connects to what box, but it's pretty simple because they're just coaxial cables.
George asks, my home load panel has two ground rods connected by thick wires. I wonder if wires might not be ideal for RF grounding. Should we improve the ground connection for radio use? And if so, how?
Hmm. Well, in radio broadcast, as I mentioned, surface area on a conductor is important. So when we do like number 6 ground wires, I mentioned stranded because there's more surface area on the individual strands. Even if they're touching each other, it doesn't matter as long as there's exposed surface there. So in my mind, I get about twice the grounding capability out of stranded. Number 6 is a pretty standard. Now, 2 ground rods, well, 4 is better. And they all tie to the same place, the same single point ground where your electrical service entrance is. And that's the one and only place where neutral and ground are connected together. All subsequent panels have separate ground and neutrals.
Very good. All right, we have time for one more question. And while people are composing it, I have a question about documentation. So the internet, in general, do you find that documentation has improved with the advent and growth of the internet? Are you able to find out things more easily than before?
I think so, but I could be misled. For a friend, I was looking at G5RV and he says, well, that 450 ohm ladder line, it doesn't work well in my situation. I found a reference to, oh, make it any length you want. And then after thinking about it, I thought on a G5RV, it's no longer a G5RV if that 450 ohm ladder line is some other length. So not all information is true there, but it is a wonderful resource.
And Robert asks, aren't the new LED lamps also adding RFI?
I've done some testing. At my place, I have about 150 4-foot tubes, LEDs that replaced fluorescence. And I was really worried about it. So I got some and there's a very small amount of RF created by them, and the cumulative amount is not too bad. And so I'm okay with the ones I purchased, and it's worked out for me. And if you go into if you turn your radio on and then run and do this light switch thing in the other room, and all of a sudden there's more noise, well, guess where your noise is coming from.
Well, thank you so much, Mark, for an amazing presentation and very informative and wide-ranging question answer. Thank you to everyone that attended today. And if people want to get in touch with you to follow up questions when they see this presentation later on the Vimeo platform from Ham Expo, is there a way that you would like for them to get in touch with you?
Yeah, email is best. It's TEKI as in techie, TEKI at, and it's my domain, which is MWPERSONS.com. Techie at MWpersons.com. And if you go to that domain, you'll find my website, a very basic HTML1 website. Got a lot of information for broadcast engineers. Nothing special for hams, but you could learn more about me, and that's the email.
Thank you so much. Everyone, have a wonderful time at Ham Expo. See you next time.